In this section, we use a closed-loop pacemaker malfunction as case study and demonstrate our simulating simulation and heart-on-a-chip platform. Endless loop tachycardia is a closed-loop execution of a pacemaker and the heart during which the pacemaker inappropriately increases the heart rate. Since this behavior involves both the heart and the pacemaker, it cannot be identified during open-loop testing. In any heart, even a healthy one, random heart events can happen in the ventricles. As we can see from the figure, the signal called PVC triggers a backward conduction from the ventricle to the atrium, triggering an atrial contraction. Without a pacemaker, the signal has no bad consequences. However, with a pacemaker, the atrium sense triggered by the atrial contraction will trigger a ventricular pace after the programmed AV interval. The ventricular pace will trigger another backward conduction which will trigger another atrial sense. The ASVP pattern will persist, and that's why it is called endless loop tachycardia. The electrical signal travels between the heart and the pacemaker in an endless loop and increases the heart rate inappropriately, which can potentially injure the patient. This scenario was discovered by physicians in pacemaker recordings, but it is impossible to recreate the behavior using open-loop testing. The pacemaker has only 2 leads for sensing. As a result, the same input sequence may correspond to different heart conditions. In the ELT case we just saw, the first atrial sense event was triggered by heart signal generated from its natural pacemaker. The other 2 events were generated by backward conduction, but the pacemaker treats them with no differences, leading to inappropriate behavior. Now we demonstrate the ELT behavior using our simulating simulation. The left-hand side shows the MATLAB GUI and the right-hand side shows the simulating pacemaker model. As we can see, a PVC triggers the retrograde conduction, which triggers an atrial sense in the pacemaker. After the programmed AV delay, a ventricular pace is triggered, triggering another atrial sense and the ELT is initialized. Now we demonstrate ELT on the heart-on-a-chip platform with our heart model implementation interacting with a real pacemaker. A user interface is designed to monitor the interaction between the heart model and the pacemaker. Currently, the heart is beating at a healthy 75 beats per minute. We can change heart condition by selecting Save Condition from a drop-down menu. During bradycardia, the heart is beating at a unhealthy 41 beats per minute. When the pacemaker is connected, the heart rate is restored to a healthy 70 beats per minute again. So when can a pacemaker go wrong? If the pacemaker is connected at the wrong time, the signal will enter a feedback loop, which drives the heart rate inappropriately fast. This scenario is referred to as the pacemaker-mediated tachycardia.